Okay, I'd like to get started with the first session. Monica Berto is going to be talking about who is more likely to submit a 311 request.
Good morning, everyone. How are y'all today? Good. So my name is Monica. I am a master's in data science candidate from American University, and I just started my new role at AFSCME as their data scientist. And I'm going to be presenting more about my schoolwork. We did a project in R, and I decided to look at 311 data. And that's my GitHub username. So what is a 311 service request? It's basically a solicitation to the local government to remediate a non-emergency issue that occurred within that local jurisdiction. So requests range and are exclusive to the following: noise complaints, which is very popular in New York City, abandoned vehicles, dead animal removal, potholes and sinkholes, that is a very popular request in DC, snow removal, street light repair, missed garbage complaint, sidewalk repair, homeless services, etc. And then a show of hands, now that you know what a 311 service request, how many of you have actually submitted one yourselves? I'm not surprised by the room. It's actually, yeah, a very low amount, but maybe that will change after this presentation. So where are 311 services available? The service actually launched first in Baltimore, Maryland in 1996, after they did an analysis where they looked at 1.8 million 911 emergency phone calls that were actually not an emergency. So 60% of those were not an emergency. So with that, they had a grant with AT&T, and they basically came up with 311, which is the non-emergency number. Since then, 311 service has actually launched in 80 cities across the United States, 20 participating cities in Canada, and also Latin America has adopted this 311 service request in countries like Panama and Costa Rica. So with that, this kind of like movement called Open 311 came about, and it's basically providing an API standard for future web applications that are accessible and decentralized. Since we have mobile apps and a lot of cities have created mobile applications, especially DC, they have their own mobile app. People can log in 311 requests through there. And we've seen cities store their millionth 311 request in their own 311 database. So why is this important? For transparency, for accountability, accessibility, and then infrastructure for future 311 data apps. Is there anyone here who works for like Lab DC or the local government, or have previous roles? No, not in this section. So it's important also for you, not just for the government to create these web applications, but it's also important for you to have transparency, right? We all pay hard earning taxes, and if our streets aren't being prepared, if our garbage isn't being picked up, this helps us have a sense of accountability for our governments. So 311 open data is very important. So before even looking at the data, I came up with a hypothesis, and my gut feeling was wealthier neighborhoods utilize 311 requests more than neighborhoods where poverty is present. So basically a measurable hypothesis is income has a positive effect on the rate of 311 requests per 1,000 people, and poverty has a negative effect. The reason why I thought this was since more cities have 311 data applications, I thought, well, who can own smartphones? People who have more money, people who have data plans, right? Data plans are very expensive, they're like $100 a month, people who have access at home. So that was my gut feeling, that wealthier neighborhoods utilize 311 request services more than neighborhoods with where poverty is present. And also just because areas that are wealthier have more people, so that there will be more demand for like trash removal or rat infestations, etc. So with that, I used R to look at 2 data sets. So I looked at the American Community Service 2017 5-year estimate. So it's available as an R package called ACS, and it actually queries from the Census Bureau API. So all you need to do is sign up for an API key and you have access to not just this survey, but many other surveys that they have. It is a little daunting in terms of, obviously there's just 66,000 variables and you have to understand the table names, the variable codes, right? You want to make sure that you're extracting the right information. And since I had the data at a zip code level, I had to make sure that I was extracting this information at a zip code level as well. So with that, by zip code, I was able to extract total population, male counts, because I wanted to see the percent of males, median household income, median age, white count, and black count for races. And then I also use another R package called R Socrata. Socrata is a really cool API. It houses a lot of different government data sets and also NGO data sets. So 311 data is not the only data set available through R Socrata. And you basically query from the Socrata API. And through that, I was able to access Baltimore's 301 data set and New York City. DC is not available in the R Socrata API, maybe in the future will be, but I downloaded the DC data sets through opendata.dc.gov. And I'm looking at 3 years, so 2016 through 2018, for these 3 cities. So this is my sample across every zip code. So some of the challenges, as we know as data scientists, the unglamorous side is having to clean the data all the time. And I was very surprised that the data sets that belong to those cities actually had zip codes that did not belong to those cities. So like, just because you assume data has been tidied and like verified, like always make sure that you're validating it. So I had to remove zip codes that did not belong to those cities. Also understand the limitations of some packages. So maybe it's the limitation of the R Socrata package, but when I was querying through New York City, at once it was way too big and my computer kept crashing. So I had to learn how to aggregate at the API level. So I just, instead of having every timestamp for New York City, I just aggregated the counts at the zip code level by the year. That was just easier. There's not a nationwide reporting standard of 301 data labeling, so every city treats their 301 data differently. There's different types of categories, so if you see in this table below, Baltimore has around 286 unique categories, DC has 159. So something like pothole removal or, I don't know, snow removal is labeled differently. And maybe the same agencies are, like the Department of Transportation are handling them, but they're also like coded differently. So that's a lot of data cleaning, making sure that you're trying to standardize the data set. And like I said earlier, learning the ACS structure, like the table names, the variable names, and the variable codes. There is documentations on the Census Bureau, and you can actually query using like rejects of like, I want all of the tables and the variables to have the word income in it. So that can help streamline your querying, but it is a little bit daunting to work with those tables. So looking at the size, Baltimore had the most logged requests despite the smallest population, which is very surprising to me. DC had the highest average rate of 301 requests per 1,000 people out of 3 cities. So if you look to the box plots, DC is in the middle and there's some clear outliers in the data. When they drilled down to the zip code level, it was museums and universities, so areas where there's not a lot of like residents, but a lot of foot traffic. So I removed those from the data set because that would like skew what would later be fed into a model. And as you see here, also like for Baltimore, it's increasing. So in 2018, the 301 data requests have increased Also for DC. For New York City, the opposite, it's actually on decline. But Baltimore at an aggregate level and per year is still has the most log requests despite their population. So I have to take that into account when I look at my model. So looking at, this is a plot density of the distribution of the variables. So that most of them follow like a normal distribution, just like percent black is right skewed and percent white is left skewed. So how to take that into consideration. But the last plots are looking at requests per 1,000. Most of the requests are under 500 requests per 1,000 people per zip code per year. So then I transformed the data. I created a table basically by zip code, by year, by city. And then I created a dependent variable. So that's basically my count of 311 requests per 1,000 people. And to get the per 1,000 people, I use the population estimate from the community survey. I also created a field called other race. So I just subtracted the white count, the black count to create that. And then I transformed the count data into percentages. So it's just like easier for the model. So example, white population would be white count divided by total population. And then I converted the city and the years into factors in R. So really quick, looking at a correlation matrix. So just pay attention to the first line, which is request per 1,000, basically my dependent variable. And this is kind of where I start to see my hypothesis is not really true. It's actually the inverse. So the last bubble, percent of poverty, is the largest, so indicating the stronger relationship. And it's at the blue scale, which means that it's around a 0.6 to a 0.8. So it's the strongest relationship to request per 1,000 versus like median income, which I expected it to be a positive relationship. It's almost either 0 or negative. So this is the first indication that actually percent of poverty has a positive relationship to 311 requests. When I look at it by city, I see that Baltimore has a very aggressive slope out of all of the different cities. So I had to take that into consideration, right? If it's like skewing my model in a certain way, especially how I said that Baltimore is the largest request out of this sample data set. But the other cities also follow a positive correlation. It's just not as aggressive as Baltimore's. And as you see, as like the confidence band like expands at the end, it gets a little bit, it's not as clear as the request per 1,000 increases. So looking at some maps, so if we look at DC, so the size of the bubbles is the request per 1,000, and it ranges from 200 to 600. And then the color scale is the percent of poverty. So the lighter bubbles means more poverty versus the darker bubbles means less poverty. So we see like Ward 7 and 8, like there's more poverty there, but the requests per 1,000s are actually in the wealthier neighborhoods. So maybe that is true in DC's aspect, but looking back at the linear line, there's still a positive correlation, but it's definitely being offset by different types of wards, right? So some wards really do have higher service requests in wealthier neighborhoods, but some have higher requests in more poverty neighborhoods. But versus Baltimore, it's a little bit more, I guess, standardized, like homogeneous. Like most of the areas where they have high requests do have a higher presence of poverty. So we see here the bubbles range from 500 to 1,500, and there's areas that have up to 0.4% of poverty there. So I used Stepwise to find the best combination of variables to see a linear relationship. The only variable it really took out was age, but it left everything else. And just at a high level, we see here percent of poverty that has the highest coefficient out of all of the other variables. And the p-value is very significant. And when I compare the t-value at almost 12, it is higher than my critical value. So I am confident in saying that areas that have higher levels of poverty would result in a higher request of 3.1, but when I look at the distribution of my classes, so like Baltimore, right, it has it behaves very differently versus all the other cities, and that kind of is explained at the R-squared level, right? It's at a 0.5, which is very high, so I feel like this model is a bit overfit if I were to generalize that. I don't think I can use this in terms of like generalizing towards all of the 80 cities in the United States. It might be just specifically for areas like Baltimore. So, which leads to my conclusion that at least with these cities, that poverty does have a strong effect on the rate of 3.1 requests, and 1% of poverty results in an increase of 23 service requests. And when I researched a little bit more about this, so according to Pew Research, 1/5 of adults living in households earning less than $30,000 a year were smartphone-only internet users, and the vast majority of Americans, 95%, now own a cell phone of some kind. And there's things like internet cafes, Wi-Fi, right? So being under the threshold of poverty doesn't really stop you from like using 301 data and like basically using your voice to like report stuff that are in your community. So some next steps, I'll probably look at different cities. Since there are 80 cities that use this, I don't think all of them have their open data available, so that would be nice. And maybe constructing different models for similar cities. So we saw how Baltimore behaved very differently versus like New York City. So maybe using K-nearest neighbor to figure out similar cities to apply different models. And then hopefully this will inspire standardization of 301 data, because that took a lot of time, just like cleaning the data set and standardizing that. And I think 301 data could also help with like urban planning. I didn't really see much research of 301 data being deployed in research. I only found one article, and that was some people from NYU looking at 301 service requests to predict urbanization. It's a very interesting read, but I'm hoping that this inspires more research on 301 data, since there is a lot of data, like I said, like millions and millions of rows by zip code level. So it's, I thought, very interesting. And I think that is it. So thank you.
Next presentation.
If you want to go ahead and introduce it.
The next speaker is Elena Rantal. She'll be speaking on generic drug evaluation and R package subbing.
Hello, I'm Elena Rantu from FDA and the Center for Drug Evaluation and Research. And today I'm going to talk about mostly using R for generic drug evaluation and a newly developed package for assessing equivalence of topical dermatological products. So since I work for a federal agency, I need to start with a disclaimer that this presentation presents my views and not my agency's views, and that all data sets shown here have been previously de-identified. So throughout this talk, I'm going to present the work of me and my colleagues at the Office of Biostatistics. So as I said, we are within the Center for Drug Evaluation and Research, and the Office of Biostatistics consists of over 200 statisticians, and we are separated into 8 divisions according to the therapeutic area of the drugs that we work with. And I'm in Division 8, which deals with generics and supports the Office of Generic Drugs. Also, I'm going to show some of the work of our colleagues at the Office of Generic Drugs, and in particular, the Office of Research and Standards and the Division of Quantitative Modeling, Quantitative Methods and Modeling. And at the end, I'm going to show a newly developed package, our package SAP. So I'm going to show or to talk about different examples related to power simulations, how to generate the distribution of certain statistics of interest, assess the similarity of and cluster amino acid sequences, determine the validity of data sets categorized for genotoxicity, characterize outliers in replicated crossover pharmacokinetic studies, compare bioequivalence assessment approaches, and also determine the important features for identifying clinical sites for inspection. So starting with an example of the similarity of amino acid sequences, this was an application for a new generic taking after a large molecule complex drug. And here we used weighted sampling and selected sequences using their frequencies as weights. We used the Tanimoto distance, and using these distances, along with our package SOM, we built self-organizing maps. And also we did clustering of amino acid sequences using the sample, either random or weighted sampling. And for each sequence, we defined the mean similarity score. Another example was one of genotoxicity data integrity. So we had to deal with data coming from the Ames test and categorizing those impurities as non-genotoxic here would be crucial in terms of determining whether additional studies would be needed to support a certain conclusion. So the data demonstrated here suspicious patterns and unusual degree of replication and very low variability. The objective was to analyze this reported data and investigate the existence, pattern, and likelihood of lack of variation, and also assess the probability of the occurrence of such outcomes. So here you can see, for example, the parallel histograms of the bacterial counts across different strains without showing the strain name, of course, but you can see how similar the data looks like here. And also on the parallel box plot, we see on the left the box plot of the reported data comparing to historical data. So that demonstrates the lack of variability in the particular data set. So what we did is we ran a simulation study, and we tried to resample from this distribution using different scenarios. So since we deal with bacterial counts, the Poisson distribution would be a plausible scenario. And since we have a very high degree of under dispersion here, we said the Compoisson, the Conway-Maxwell-Poisson distribution would be also a plausible scenario. So we used the Compoisson R package for that. And we also sampled from the actual distribution of the data and also from 2 cases of historical data. And every time we try to create a sampling distribution for a certain statistic, as for example, the coefficient of variation, the robust coefficient of variation, which is based on the median and the interquartile range, and also the statistic M that you see here, which is simply the ratio of the total number of distinct observations over the total number of observations, since we had such a high repetition in this data. So this is an example of such a sampling distribution for the robust coefficient of variation in a case that we sampled from the historical data. And it turned out that out of the 10,000 samples, only twice we observed the value of that statistic, which was as extreme or more extreme than the reported one, showing that the likelihood of observing such data was very low. Another case is that of characterizing outliers in replicated crossover pharmacokinetic studies. And when formulations are compared with respect to their pharmacokinetic characteristics, there may exist either unusual subjects, so on a subject level, or unusual observations within a certain subject, in which case we have a big difference across two replicates, either of the test or the reference product. So what we did is we used a certain statistic, DEAP, developed by Wang and Zhao, which is appropriate for the particular type of studies, of the study design. And here, this statistic is based on the residuals, and we have evaluated that statistic based on two different types of residuals. And under the two different cases, we see that we have a subject which is consistently very high, gives very high values for this statistic comparing to all the other subjects. This is an example of comparing two bioequivalent assessment approaches. And this was an example of an abbreviated new drug application, an ANDA, which is the acronym for a generic drug application for a topical cream. So a traditional approach for establishing equivalence here relies on a clinical endpoint studies and uses a success proportion as the endpoint. And by the success proportion here, we mean a 2-grade improvement on a specific scale. So the applicant proposed a new approach based on the area under the effect curve divided by the maximum effect. So what we did is that we ran a simulation study under 3 different scenarios. If the statistical test is just an equivalence test, if it is a superiority test, or if it is both, if it consists of both equivalence and superiority. And in every case, we try to assess the passing rate and of its methods. And what it turned out to be is that in the case of the equivalence test, the success proportion method, which was the traditional method, had a higher passing rate. But in the other 2 cases, the applicants' suggested approach had a higher passing rate. This is an example. It's recently published work, and it is an example of trying to use different methods and to compare actually different methods for clinical investigator site inspection selection. So the objective here was to use, for example, data mining techniques and also unsupervised learning to see if we can better predict which clinical sites should be selected for inspection. So we're mainly comparing 3 different techniques. One of them, SMART, detects outliers using distributional assumptions about the data and basically uses p-values to identify atypical or unusual clinical sites. We also had another previously developed approach, SIST, which was based on expert opinions and was assessing a specific risk score to every clinical site. And we also applied data mining approaches such as random forest and boosted tree to predict an outcome for certain existing inspection outcomes. So we had 2 cases here, a case that we had the binary outcome and a case that we had 3 outcomes, a response variable having 3 outcomes. So those outcomes were NAI, VAI, or OAI, standing for OAI, official action indicated, and NAI would be no action indicated or voluntary action indicated. So in one case, we had these three outcomes in the response, and in the other case, we collapsed voluntary action and official action indicated versus no action indicated, and we had a binary outcome. So comparing these techniques and which ones either better predicted the outcome or what was the agreement between the techniques, we created these heat maps and the bar plots that you see here. So regarding the work in the Office of Generic Drugs, I have three examples to show. Using machine learning methodology to predict ANDA submissions, the application of machine learning for time to event analysis, and testing for equivalence of complex particle size distribution profiles. So in the first case of predicting the first ANDA submission for new chemical entities based on machine learning methodology, the random forest method, the random survival forest method actually was shown to be superior in predictive performance comparing the conventional time to event methodology. And here you can see, for example, on the left is a variable importance graph, and the other one is the cumulative probabilities. Also an application of using big data tool sets to pharmacometrics. So in this case, the machine learning methods were superior this time compared to Cox regression under various simulated scenarios, and also demonstrated less sensitivity to data sizes and censoring rates. And the last example from OGD is using equivalence testing of complex particle size distribution profiles based on the Earth mover's distance. So this approach, EMT, was employed to compare complex particle size distribution profiles for equivalence assessment. And by complex profiles, we mean those whose distributions are multimodal. So the developed approach was shown to be both effective and sensitive to pass equivalent products, but also reject inequivalent products. So finally, I would like to show you a package that I have developed for assessing equivalence of topical dermatological products and data that comes from the in vitro permeation test. So I would like to first show you how this test works. It uses excised skin, it uses cadaver skin from donors, and we take identical and independent replicate skin sections from every donor. So say that we have donor 1, and we have our replicate skin sections that are dosed with a test product, and here by test product we mean the generic product. Each one of these sections is put on the diffusion cell, and it is sampled in such a way that we get the permeability values, and we construct a pharmacokinetic type curve like the one that you see on the right. And the same thing is repeated for our replicate skin sections that are dosed with a reference product. And then we repeat the same for other donors, and we have a total of n donors. So the response here is either the total penetration or the area under the curve, or the maximum flux rate, which is denoted as Jmax. And we consider a sample of n donors, our replicate skin sections per donor and per formulation. And we have 2 formulations, the test, which is the generic, or the reference. So for bioequivalence assessment, we used a mixed criterion. We have a cutoff point, and that cutoff point is the within reference standard deviation. So if this is greater, and the whole process resembles the process of assessing equivalence of highly variable drugs developed years ago in CEDAR. So if we have if the variability is lower than the cutoff point, then we go with a traditional 2 one-sided confidence interval that in order to declare the 2 products as equivalent, we need to make sure that the calculated interval is completely contained within two limits. And here by M, we mean the bioequivalence margin. Now, for us in FDA, this margin is 125. Usually it is 125, meaning that these limits, the interval needs to be contained within 0.80 to 1.25. In the case that we are above the cutoff point, then we need to use a scaled approach. And using this scaled approach, we have a different hypothesis, of course, to test. This is a mixed criterion. So we have to make sure that both the upper 95% bound of the scaled interval is negative, and also the point estimate, which is the geometric mean ratio, needs itself to be contained within the limits 0.80 to 125. So that package can very simply, by just inputting a data set in a specific format, it can test for equivalence using the mixed scale criterion, estimates the statistical power as the function of the sample size, and here by sample size we mean the number of donors, compares the statistical power of the scale to the unscaled approach, estimates the statistical power for different levels of the equivalence margin, and also can estimate the size of the test or the alpha level. Additionally, we can conduct sensitivity analysis with varying the number of replicates per donor, as well as the interdonor and within reference variability levels. We can balance an unbalanced data set under different criteria and produce graphical displays that demonstrate the variability levels and potential extreme replicate values or outliers. So this is an example of how the output looks like if we just enter a data set, input a data set, and we can get right away information about the point estimate, the scaled and then unscaled confidence interval, as well as the variability level. We can also create nice graphs like this, comparing the power curves of different pharmacokinetic metrics, and also compare the power, as we see in the bottom graph, between the scaled and the unscaled approach, and also estimate the alpha level. Here we see that for the scaled approach, SAB, the alpha level for different sample sizes is always bounded under 3%. Finally, some references, and I would also like to acknowledge the help and guidance of my colleagues at the Office of Biostatistics and the Office of Generic Drugs. And thank you for your attention.
I think we have time for a question or two.
And who's next?
Yep. Our next speaker is David Kretsch, using Amazon Web Services in R with the package Paws.
Thanks. Yes, I'm going to be talking about using Amazon Web Services, or AWS, in R using an R package called Paws. So today I'm going to talk a little bit about what you can do on Amazon Web Services, how you can use it from R, and then one specific use case that we originally conceived doing in processing big jobs on R, using Paws, in R, using Paws, and running it on AWS, using a service called AWS Batch. So AWS has a lot of different services. It can be overwhelming. Some of the things that you can do with it are process data, process large amounts of data on big hardware. So you can get servers using their EC2 service. EC2 stands for Elastic Compute Cloud. You can get clusters of servers. They have a service called Elastic MapReduce, or EMR, and these run Spark and Hadoop. You can do batch processing, and we're going to talk a little bit about that later in this presentation. They have several database services. So if you want to run a relational database like MySQL or Postgres or Microsoft SQL Server, they have their relational database service, RDS. If you have data that you want to analyze with a data warehouse, they have a Redshift service. If you want to run a NoSQL database, they have DynamoDB, among other things. And then you can also store files, large amounts of files, inexpensively using their simple storage service, S3. And this isn't comprehensive. This is just some of the most popular services. They also have a lot of machine learning oriented services. So things like building machine learning models, translating from one language to another language, speech to text, text to speech, natural language processing. They also have lots of services for connecting applications together, such as like putting things in queues, sending out notifications, sending out emails when something finishes. If you're running servers, you can scale those servers up and down in response to events. You can run individual functions without running servers, using their functions as a service offering. So Paws is a way of using all of these services from R. And in this example code here, we want to use the S3 file storage service. So we create a client. This is the thing that connects to the service. And we've created a client called an S3 in R. And then inside that S3 client, we have access to all of the different operations that we can perform on AWS using S3. So this second line down here, this list objects, if I want to see all of the files that I've uploaded to my S3 bucket, so-called, which is kind of like a folder, I can use this operation. There are also lots of other operations. We have some online documentation that will show you those. So things like uploading files, downloading files, showing all of the folders or buckets that I have. And so these kind of, these assume that you have provided your credentials. There are a couple of different ways of doing that. We're not going to talk about that. We have documentation on how to do that. So another example using a different service, DynamoDB. DynamoDB is a database which can store data of that is not structured in the same way that a SQL database is structured. But in this example, we're uploading some information about a song to a table called music, and I'm using this an operation called put item. I'm uploading it to a table called music, and I have some information about the item that I want to put into that table. So every single service you connect to separately, and then every single service has a bunch of different operations you can perform on that service. All of this is available in the documentation. There's online help as well. If you're using RStudio, it'll auto-suggest things. So the example that we wanted to talk about today, that was the original motivation behind developing this, by developing Paws, which, by the way, developed by my colleague Adam and I, was that we had these big forecasting models that we wanted to run that were developed in R, and they were highly parallelizable. So, you get twice as many processors, it'll run in half of the time. So we wanted to run these on giant machines, but we wanted the people who are developing those, the analysts, the developers, the statistical programmers, we wanted them to be able to run these on big machines without having to learn all about AWS. So they should be able to kick it off from R and have something in the background take care of that for them. So AWS Batch is AWS's offering that allows you to run your jobs on a big machine that AWS starts and shuts down when the job is done, so that you're not paying for it, all the time, because these machines can be pretty expensive and you wouldn't want to run it for an entire year. So AWS Batch runs a job on a big machine that it starts and it'll stop when it's done. Batch uses Docker containers to run your code, so we're not going to talk about that. A Docker container you can think of as a self-contained package with an operating system like Linux and any other software that you need, so things like R. So we say here that you need to create one, but we have an example later where we use a pre-built container. So you don't have to do this for this example. And you tell batch what kind of machine that you want to run. I want 72 cores, I want 128 cores, I want 2 terabytes of memory. And assuming that your environment allows you to start a machine that big up, it will go ahead and do that. And then we are working on a library that will do all of this for you. So all you'll have to do is say, I want to start up this, I want to start up batch, I want to start up this job, and it'll go and do that for you, provided that you have credentials and whatnot. So the way this works, and we have an example that we can't show today, is that you are in R over on the left-hand side, yes, over here. And the first step is, so you have some R code that you want to run in batch. The first thing you're going to do is you're going to, oh, sorry, I didn't realize that was, sorry about that. So the first thing you're going to do is you have your R code. It can be an individual file. It can be a set of files that you've zipped up. You're going to send that to the S3 file storage service. So this is step 1 here. Step 2 is you're going to tell AWS Batch that I want to go and run this job, and I'm going to tell it the location of the files that you just uploaded. Step 2. So so from that, AWS Batch is going to start up whatever kind of machine you wanted, 64 core machine with 500 gigabytes of RAM. It's gonna download the files that you uploaded. It's gonna run those files. It's gonna do whatever it is that what your R script is supposed to do, and then it's gonna run it and output wherever you want to output it to, and then it will shut down when it's done. So if we have a forecasting model that takes 6 hours for us to run on a small machine, we can go and run it on AWS Batch on a machine that's 10 times as long, and it'll take 1/10 the time. So a little bit of how that would work in Paws. So number 1, you send your R script to S3. We use this S3 connection. We upload that file using this put object operation. And then number 2, we need to submit a job to batch. Basically tell batch, go and run this for me. And then, so we use this submit job operation with some parameters. Then AWS takes care of the rest for us. So batch starts up the big server. And then that big server will fetch our code that we uploaded in step 1. It will run and it will output to wherever we want to output it to. So it can output back to S3, it can output to a database that we've set up, what have you. So this is where I would have shown you an example of starting up a big server, but they told me that I couldn't use my own laptop. So we actually have I hope this comes up, a repo where there's a whole bunch of, there's an example code here with instructions on how to use it. So this is the example code. So we have it, sorry, that's really tiny. So upload to S3 right here, and then we run using this submit job, and I've told it I want 64 CPUs. I can tell it, what kind of machine that I want. It would go and start up a machine that matches what I'm telling it to start up. It'll run and it'll shut down. So how do I get that? Yeah, so you couldn't see the exciting part, unfortunately, but we have a lot of resources for you to learn more about using Paws, using AWS. So Paws is on CRAN, so you can install it from R using install.packages Paws. We have a website that was actually put together by one of our interns, which I'm really happy with. So you can see our online documentation. So this shows you all of the different services that you have. And if I click on one of these, so let's say CloudWatch, you can see here are all of the operations that I can do with this particular service. And then you can also visit our GitHub page if you have a question or an issue, or you run into a bug, or there's some feature that you expect to be there but isn't. You can go ahead and make a request. We also have a bunch of examples. So here's some examples with DynamoDB, for example, that you can just copy and run yourself. And then lastly, so going back to, so going back to this, so we also have some hex stickers with our logo if you want to come up and get some. And that's all I have. Thanks.
We have time for questions if anyone has
For any of the speakers.
for any of this.
Yeah, quick question. So is there something you found lacking about other R packages that connect with AWS, and that's why you went with making your own?
So the issue with AWS and R is that there isn't a comprehensive set of packages for dealing with all of the different services on AWS. There's individual packages for one service at a time. We wanted something that would allow us to, for example, AWS batch. There was nothing that was available. And we thought, hey, well, if we're going to develop something for batch, why don't we develop something for all of them? So this is like a comprehensive package that's similar to the software that would be available in other languages like Python or Go or JavaScript.
Any more questions?
We'll go ahead and call the next speaker then.
Our next speaker is Samuel Rowe, talking about using the current population survey to answer DOL relevant questions, applications in R.
Hello, my name is Samuel Rowe, and I'm with the Chief Valuation Office in the U.S. Department of Labor. And today I'm going to talk about a topic that I kind of work with a lot with the different agencies, leveraging the current population survey to answer questions. The applications I've been used are in R, but actually we have other open source data I'll get to. So kind of want to give a brief introduction of the Chief Valuation Office, kind of what we do. Then I want to talk about our DEAP platform, data exchange and analysis platform, and how we can use that to support the agencies in the Department of Labor to build capacity and answer questions. And finally, we're going to talk about how we're going to estimate the Fair Labor Standards Act. So the Fair Labor Standards Act is, which I'll talk a little bit more a little later, is it's a law that covers most working Americans, but there's no data set you can actually go out there and get it. So we're going to use this current population survey to get estimates. And then we're going to talk about how program relevant questions can be answered and how potentially policy relevant questions be answered using data as opposed to, well, I think I have this gut feeling. How can we have data informed decisions? So the Chief Valuation Office is located in the Office of the Assistant Secretary for Policy, but we're an independent agency. There are 5 pillars for CEO and for conducting program evaluations: relevance, transparency, rigor, ethics, and objectivity. And so what we do, how we assist agencies, is we come up with a learning agenda. And if you know the implementation of the Evidence Act, this is something that's across all agencies now have to have learning agendas. So what learning agendas do is programs lead with a question. I want to know about this. Is this effective? Is this feasible? What are the how are these programs implemented? These are the questions that agencies come with us. So you need to lead with a question as opposed to what are the tools that I have. So that's one of the most important things that this chief evaluation does. We have these learning agendas. Now they're actually going to have multi-year learning agendas, which I won't get into today, but most agencies are on the docket for that in terms of the Evidence Act. So we work collaboratively with the agency, whether it be the Women's Bureau, the Wage and Hour Division, whether it be, gosh, I'm trying not to use the acronyms here because the government's really bad about acronyms. Oh gosh. So the International Labor. Oh gosh, I'm trying to think. I apologize. You get so used to acronyms, you get lost. But we work with different agencies, such as Wage and Hour and Women's Bureau, the Office of Disability Employment Protections, to come up with questions, and then we go out and we have we try to answer these questions. Now, there are two parts here I want to talk about. I'm with the analytics team. It's a much more internal consultative team. There's actually only just two of us. But we work on a consultative nature to build capacity and answer questions. Now, the evaluation side is much more broad focused. It's they conduct large third-party evaluations to do implementation studies, feasibility studies, impact studies using RCTs or QEDs. So I'm actually going to focus on the analytics team, where I am. We work with agencies and to help build capacity, but the method is still the same. What is the question? You got to lead with the question. Don't lead with the tools. Well, in order to help answer the questions when agencies come to us, we have our data exchange analysis platform. This is it's basically a web-based client for people to hop on there to get access to Dockerized containers for open source software, such as R, which I mostly use, Julia, Python. We have other ones, Stata's coming online. SAS will eventually be transitioned over. But we have multiple tools to help the agencies answer questions. I mostly use R. I started with Stata, so I love it, but I'm 90% of the time I'm using R, actually 95 probably. But it's a hub and spoke architecture. So basically, you upload your files onto the server, and then you go out and you can use whatever tools you want to reach this clustered file system. So we can host large data sets. You can put years and years of CPS microdata on there. You can put the ACS microdata on there. So we provide that service of having stored in large containers, without having expensive web services, which will eventually then transition to the cloud. But for right now, it's a kind of a half cloud service because the agencies, when they get on there, it actually uses a web-based client. So there's no installation, there's no dealing with OCIO, the Chief Information Officer, that, hey, I need a request, I want this version of R, I want this version of Python. No, you just hop on there, and we got our Dockerized containers, you just use them. Minimize that bureaucratic red tape. Just hop on there, get your data on there, and start working. And we work in collaboratively with the agencies, so we're not working in silos. One of the biggest things, when you think about labor, you think like, oh, well, it's one agency, lots of people work together. No, we got these silos, and we're very much in the business of not only building capacity, but breaking down silos, because people don't talk to each other, and it's bringing people together for collaborative, so we can actually use data to have data-informed decisions. And finally, we actually have, through the DEAP server, you can load up your data, work on your data, and then visualize your data. So actually, our Shiny server is something that we're eventually we're developing we're testing right now and developing. We'll hope to have it in production fairly soon. It gets away from Tableau. I know the representative of Tableau here, but I'm not the biggest fan of Tableau. It's a great tool, but Tableau is great, especially for getting in there. So, but I'm a Shiny fan. But Tableau is great too, so I don't want to step on anybody's toes. But the ETL pipeline, load up your data, work through what client browser, whatever tool you want, and then visualize. So what I want to talk about today is kind of application that we've done that has supported multiple agencies. The Fair Labor Standards Act is a very important law under the Department of Labor. created in 1938. It's been amended multiple times, and the one I'm focused on today is the 2004 major revision, and then moving forward. It affects all types of workers. So even you may not be exempt from certain overtime, you are covered from it. And it basically establishes minimum wage, overtime, prohibits child labor, and also establishes having record keeping standards. And more information can be found here under the DOL wage and hour division. Feel free to check it out if you'd like, but more information is there. So, but the thing is, we don't have it. The statistical agencies, I love them. They're great. They have such wonderful data, especially the current population survey, but we don't have an estimate of the Fair Labor Standards population. We can get wage and salary workers here. We can get all working adults, all types of information from the current population survey, but I can't see who's covered by the Fair Labor Standards Act and are you non-exempt. So what we do is we have a methodology to estimate it. So the inputs, the current population survey, which has a wealth of data, labor market data. I don't know, I'm sure most people here have used the current population survey. At least if you're in labor, I'm sure if you haven't, please go check it out because this is amazing. So I use it for my dissertation, constantly, almost every day. But so from this microdata, we can tell a person's earnings and what occupation they're in, what industry they're in, locations, age, all types of important information we can test for to see if someone's covered on the Fair Labor Standards Act, and then are you exempted under minimum wage, overtime, or both. So the biggest thing for coverage for 500 is 500K. So do you work in an establishment that has $500,000 in annual revenue? That's kind of the biggest one. And then we want to remove self-employed because they're not covered. But then we got to go into certain ones. That's for coverage. That's, I want to say, almost 110 million workers out of 140 salaried wage and salary workers. So that Fair Labor Standards Act covers most workers. But then we got to see if you're covered, if you're exempt from minimum wage or overtime. So what we do is we test binary exemptions. That's kind of, it's binary, 1-0. But we also have probabilistic, such as the EAP, the Executive, Administrative, and Professional Exemption, kind of known as the white collar exemption. You have a salary test and a duties test, and it's kind of based. So we have to estimate this on a probability as opposed to a binary exemption. And then the next step is estimating an hourly regulated rate. So you may be salaried, but you're still covered by the Fair Labor Standards Act. So we got to calculate an hourly rate to see if the regular rate, so wages and tips and commission, overtime covered. All this information is in the current population survey. So we're able to run through the methodology and then get outputs of microdata that have been augmented for exemptions and then potential violation estimates. So we have all the wealth of all the demographic and labor market characteristics at the micro level, in addition to FLSA information. So we can actually have a great data set. We can actually answer some questions. So like I said, when agencies are interested in having data-informed decisions, it's important to lead with a question. A lot of times agencies come, I'm interested in machine learning. How can I use a QED? Well, what's the question? What is the question? You always have to lead with the question. And when we do this, they come with a question, we use the appropriate tools and methodology and data, and then hopefully it'll come up with new questions to help form new data-informed decisions. Not data-driven, data-informed. So like I said, it's an iterative process. So hopefully when new questions come up, hopefully results show new questions. Like, oh, okay, I see what's going on here in this region, or what's going on with this district office, or what's going on with this occupation. I want to know more. So that's always helpful in that, at least in the process. So I'm going to go over a few questions that are program relevant. So how many workers are covered by the Fair Labor Standards Act, and was this trend over time? And how does that compare for who are covered non-exempt under minimum wage? And other Other potential ones are you covered by the proportions? Are they consistent across industries and states? I don't answer all these, but I will just kind of take a look at this one here. So this is starting 2004, because that's when the major change happened. Here are wage and salary workers, FLSA covered workers, and FLSA covered non-exempt under minimum wage. And as you can tell, the blue line on top is the wage and salary workers. You go get this. This is pretty much a bench. You know, the wonderful thing about this, you can go benchmark to BLS. You calculate the wage and salary workers. I see BLS has the same thing. That helps also quality assessment too. So not only what you're doing, you know, it can be benchmarked. I worked at BLS for a while, and verification is a very important process. So benchmarking to the CPS, actually published CPS numbers, helps corroborate what you're doing. Below that is the red line. I believe it's red. I apologize. It's not byway compliant, and I do have red, green color deficiency. So red, green get confused. But the solid middle line are those who are covered under the Fair Labor Standards Act. It's fairly consistent because the biggest one is the 500K exemption, 500K coverage, and it's fairly consistent. You can see those two fairly move fairly similarly. But what's interesting is how those workers who are covered in non-exempt under minimum wage have actually been fairly flat after the Great Recession. It's moved up a little bit, but those who are covered non-exempt have been diverging from wage and salary workers and also covered under the Fair Labor Standards Act. So that might lead to an interesting question of why. Well, maybe something's going on exemptions. Maybe we should update the exemptions. Maybe that we're not interested in updating exemptions. Maybe we want to deregulate, depending on the administrative policies. I'm not getting into that. It's just data-driven visualizations. So if I'm the wage and hour, so okay, I see who's covered, but I want to know about violations. What can I know about violations? I want to know what state has the highest prevalence. I want to know what occupation group has the highest rates. What are the trends over time? And then ultimately, I want to know something about the characteristics of those who do have a violation. And then if we're interested in that, we can actually even want to bring external data in. So basically, if we are having oil and gas mining, what happens with the price of oil and gas? I can bring that data in and test that. ACS, the ACS is amazing. I can't, the track data, I know the first presentation had something on ACS, and I wholeheartedly support that. It's just amazing. Get the track level data. You can get track level data or the MSA level and combine it with what we have here, with what you have. So estimates of Fair Labor Standards Act violations. The top line is overtime, and the bottom line is minimum wage. And actually, some really interesting trends can pop up here. So overtime is typically more prevalent than minimum wage violations, but minimum wage violations have actually been declining while overtime has been increasing since the Great Recession. So it's interesting here. There are actually, you can ask questions here, but this is only correlational. You have to establish an appropriate QED or research methodology to assess causal inference, which I'm not going to make causal, but you can see that there is a correlation with the Great Recession and overtime. Typically hours have dropped. Makes sense. Fewer workers, less demand for hours. So overtime has dropped, but ever since the end of the Great Recession, overtime violations have been increasing. While minimum wage, it's tricky here because you see like, oh yeah, it makes sense. The Great Recession hit. Well, 2007, 8, 9, minimum wage went up as well. How do you disentangle that? That's the challenge. One thing you can go back, you can try to estimate the discontinuous jump in the rule change 2004 and then test 2001. See if minimum wage violations went up or whatnot, or you can have another QED methodology to tease that out. But correlation is not causation. But so I want to know something about the what states. Okay, well, what's your interest? Is it rates or violations, total violations? Am I going to try to get the most, or I want to know something about states that are a little bit smaller but have higher rates? So actually, you can see here in Indiana in 2018, they actually had a overtime violation rate higher than Illinois. was about 9-something% compared to a little over 7.5. So actually, Indiana, while a small state, it may have fewer violations, but the violation rate for overtime is higher. Minimum wage is about the same. Ask questions. Maybe one's a right to work state, one's a union shop state. That's an interesting question that may or may not be read in my dissertation. But you actually go to levels of violations, you actually can see that as Illinois is a bigger state, more people, more violations. California, Texas, these will pop out in most violations, but actually do by violation rate per worker, the results change. So if I'm interested in seeing like, well, what's the state that I haven't put enough resources in, maybe a rate might be, but if I'm trying to get most bang for my buck, then, well, maybe the total levels might be more important. So we can do by occupation. We can, no surprise here, for minimum wage violations, waiters had the highest minimum wage violations, zero surprise. Maids, cooks, cashiers, actually school teachers, retail salespersons kind of pop up in some of the top 10. But if we actually go over to overtime, it's actually quite a bit different, definitely a different set of workers. Miscellaneous agriculture workers pop up, welding and soldering and raising workers, electricians, drivers of taxis, is that taxis? Truck drivers, excuse me, and production workers. Actually, a lot more manufacturer production work here. So it kind of pops up a little bit different from minimum wage overtime violations. So those are kind of visualizations, potential questions that maybe the wage and hour division has. But what about if I'm a policy shop and I'm interested in writing a new rule? Well, I want to know how a new rule could affect the Fair Labor Standards population. So I'm interested in implementing that. Who's covered? What? Who's potentially impacted? When you're writing the proposed rules for the Federal Register, these are important things to consider. But maybe you're interested, what if I want to change the salary test and the EAP exemption, the Executive Administrative Professional exemption? What's this trend over time? And what if I'm interested in moving it from $913 a week up or down, depending on which. I'm not getting there. I'm not touching any politics or policy. This is just data-driven decisions. We actually can see under the EAP exemption, the red line, the top line, are those who are non-exempt under our salary workers, non-exempt under the Fair Labor Standards Act, and the blue line is salary exempted under the EAP. And we can tell that with wage inflation, growth in wages, more salary workers are hitting that EAP exemption and exempting out. So you can see the increase in the dotted blue line, while the salary workers not exempt on the EAP has been falling. So if I'm interested in changing that 913, what would happen? Well, we can use the CPS, we can use this data set to answer that question. So future work is generalized variance functions. When you do these are estimates. Important to have standard deviations. We have done that for industry level, but it'd be important to move that beyond industries, occupations. I know states aren't there, unfortunately, but it's important to have confidence intervals around these estimates. Taking into account factors and correlates of FLSA. This is actually a project that's we plan to do with Fair Labor Standards Act. What are the factors, characteristics, establishment, household, and personal, SES, demographic characteristics with wage and FLSA violations. And then ultimately, we're going to move this to the Shiny server so we don't have to worry about putting out from our DEAP server out to Tableau. Basically, it goes from the DEAP server over to our Shiny server, and you can have a dashboard, send out the link, and then everyone click it. You don't have to worry about licenses and all that other stuff. So I appreciate it. Thank you for the time, and I appreciate it. Thanks.
So I think we have about 5 minutes before the networking session. We'll open it up to the floor for any questions for any of the 4 presenters, and thank all the presenters again for their contributions. If not, I'll go ahead and pose a question for some of our speakers regarding cloud-based services and things like that. Some of our federal agencies are kind of at an in-between where they're trying to make the jump to cloud-based services, and there are a number of bottlenecks or considerations that go to that. One thing that's been on my mind is how do you equip a staff to start learning how to interact with, say, Amazon Web Services or Microsoft Azure or things like that. So I'll pose that question to the floor, and if you want to come and answer, that's fine.
I mean, I guess this is kind of, so like learning about AWS is like completely different skill than doing data science. I mean, there's a connection, but I think what you would find is that, you know, if you have some members of your staff that have an interest in that, they're going to like move in that direction, and they're going to be spending their time like learning about AWS or Azure or something like that. And there's a connection to, you know, doing data science, but I think in the sense of like statistics. But there's a whole lot of other stuff involved in setting up the infrastructure and connecting it to the thing that you are actually trying to do, which is this big analysis, you know, estimating models, getting results. So, I mean, I think it's something that you have to, you know, assuming you get all of the, I guess, roadblocks out of the way, like making sure that you're allowed to use it, and that, like, you know, you have a platform set up that like meets your agency's requirements. It's going to take some time. You're going to have to set aside like some people to learn about, you know, what do I need to do on Amazon? They're going to be, you know, dedicated to doing it at least some of the time. So it isn't, you know, we were thinking, hey, we want to make it our data analysts, our developers able to use AWS, but it isn't that there is nobody who specializes in AWS. There's other people who are enabling them to run things on AWS or on Azure or what have you. I hope that helps a little bit.
Along those same lines, does AWS sort of track by user? So do you have like metrics to see like how diffuse that got after you released the package, to see like how democratized it became?
So, I mean, I'm not going to lie, this isn't a super popular package. You know, we put it up on CRAN earlier this year, and I think it's on its good days, it's in the couple hundred downloads a day. But I think a lot of those is every time that we push a new version to our GitHub repo, it automatically tests. So it's doing some of the downloads. I don't think it's like, we've gotten some feedback, some like bugs from people all over the world where we have no idea how they're finding out about it. But I'm not going to, you know, say that, you know, this is super popular right now.
But in your organization,
oh,
have you seen it being adopted, and that do you see the skills kind of diffusing out to people that might not be engineers but are data scientists?
So, you know, our original motivation was that people would be using this to go and run stuff on AWS, like in R, but that project actually went in a completely different direction. So we ultimately didn't end up using it for that. So there aren't really people in our organization using it because they are now using some other statistical software, you know, unfortunately. So we do have people who specialize in like AWS, but, you know, we're not using it to run these big forecasting models. So short answer is no, like people aren't developing skills in that because the people who are developing skills in AWS aren't doing the thing that we originally built. So that's probably not a super helpful answer for you. And I'll leave some of these stickers up on the table, I guess, in case you want to pick them up.
Are there other questions? Oh, yeah, I'm sorry.
Yeah, so I know for our data and exchange announcement platform, it's kind of quasi-cloud now, but it's basically being prepared for eventual transition fully cloud. So it's getting the there, but the environment, the file system, and all the one. But as in office, they still interact with the web browser or our studio or Jupyter notebook. Make it as easy as possible. So that's something that is coming down the line for Holistic within DOL. It's taken our platform. It's our quasi-cloud now, but it's
I think we're about on the half hour here. So we've allotted some time for an informal networking session. I'd encourage you to introduce yourselves to some of the speakers or to the people next to you. And we'll resume again, I think, at 10:45 with the next session.
Hi.
This is from 1 and 2, right?
Yeah.
Okay.
You may want to make sure yours is on here. Is that, are
Pretty
you,
sure that's not on
it's
there.
not on there?
That's what I'm
Okay.
having.
Okay, yeah, 1 second.
Yeah, sure.
Pretty sure these are all unlocked in our conference center computer, so it should just work.
Okay. Are you going first?
No, I'm in the last session. I
Oh.
haven't given him my talk either, so I was taking the break to picture.
Okay. Yeah. Did you try to see whether it works in the presenter view and all that?
I did not at all.
Oh.
Then I plugged in to make sure it outputs to the other one. Yeah, it takes a minute.
Okay. All right, so it's,
It looks like they turned it on.
should, never mind, I got my notes. So,
Yeah,
yeah,
I think sometimes they turn it off because they're on Zoom
Right.
or on WebEx, so it doesn't show the notes page to people.
yeah. All right, thank you.